Hello students, Dr. Bhavani Regmi here. Today we are continuing on our type of chemical reaction and then we will explore into moles and Avogadro's number. The very last type that we did not complete in earlier lesson is the redox reaction or oxidation and reduction reaction. Okay, this is a special type of reaction as the single replacement reaction and combustion reaction can also be a redox reaction. Okay, so now let's look on what do we understand by oxidation. Okay, oxidation is a process of the loss of electron and reduction is the process of gain of electrons. Okay, so oxidation is always, okay, oil rig is the mnemonics we use. Oxidation is loss of electron and reduction is gain of electron. Okay, we can define whether certain process is oxidation or reduction by keeping track of electrons, whether they are lost or they are gained. Okay, and oxidation and reduction process take place together simultaneously in a redox reaction. So that's why a redox reaction always has a component. The one that is undergoing oxidation is oxidized and the component that is undergoing reduction is reduced. Okay, so we will find oxidized and reduced species in a reaction, in a redox reaction. So that's why we call a redox reaction involves the transfer of electron. One of the partner or participant will lose the electron, the other participant will gain the electron. Okay, so let's see this with an example. Okay, let's say we have a reaction of a zinc metal in a copper solution. Okay, here you can see that zinc in the pure neutral atom, right? It does not have any charge in them. So you can call it is zero, right? So zinc is losing the electron and forming the zinc ion here. Okay, in this reaction, zinc from neutral state, it is going to the charged state and it is 2 plus charge means zinc is losing 2 electron. And during the reaction, our copper ion, which is the reactant, which has the 2 plus charge, will gain the electron and it will become a neutral element. So zinc is undergoing oxidation by losing the electron. Copper ion is undergoing reduction by gaining the 2 electrons. Right? It was positively charged, it gained the negatively charged electrons, the charge is balanced and now it has no charge on it. Right? So we write our equation zinc with copper ion gives us zinc ion and copper metal. Right? Here zinc undergoes oxidation, so we call zinc is oxidized. Copper ion undergo reduction, so we call copper ion is reduced. Okay, similarly we have 2 more vocabulary here. A compound that is being oxidized is always become a reducing agent. Okay, so in this case zinc is the reducing agent. A compound that is being reduced or the compound that undergo reduction is a oxidizing agent because this compound brings oxidation to another partner. Right? So here the copper ion is the oxidizing agent. Okay, so remember this, that a compound that is being oxidized is a reducing agent and the compound that is being reduced is the oxidizing agent. So it is the game between the oxidizing and reducing agent to bring the redox process together. Okay, so that is the special type of reaction, oxidation reduction reaction. With this, we are now looking into the second part of our chapter 5. Okay, so let me open that up. I might have it here. Okay, let me put that on the slide. Okay, so the second part of the chemical reaction, we will explore about the mole. Okay, this is not the animal, the creature mole, but it is a quantity that we use in chemistry. Okay, so what do we understand by a mole? A mole is a quantity that contains 6.02 times 10 to the power 23 atoms. Okay, you might be thinking why we are using mole, why we are studying about mole. Isn't studying just about the atoms and chemical reaction and this many atoms react with that many atoms? Wouldn't it be easy? Right? The thing is, we could explain that way, but atoms are exceedingly small, right? So when they are so small, we need a large number of them to talk about, right? So we use mole in that case. A mole is something like a dozen, okay, or like a pair or a case. So when we say a dozen of bananas, you go with 12 number, right? When you go with a dozen of grapes, 12 grapes. A dozen of marble, 12 marbles, right? Or a case of soda can, there should be 24 of them. Am I right? A case of soda can, 24. Or like something like that, right? So when we say a dozen, we go by the number 12. Just like that, when we say a mole, we are talking about 6.02 times 10 to the power 23 number of moles. Okay, I want to explain that way. Yeah. So when we say 1 mole of something, we are talking about 6.02 times 10 to the power number of that. Okay, so 1 mole of carbon atom means 6.02 times 10 to the power 23 carbon atom. 1 mole of donut means 6.02 times 10 to the power 23 donuts. Okay, so when I say 1 mole of something, I am talking about this huge number of that thing. This huge number is known as Avogadro's number. This is 6.02 times 10 to the power 23. You want to memorize this number. Okay, it might be there in the formula sheet, but it's better to memorize it because we are using it so much again and again, it might become as a second nature to you. When we say 1 mole of water molecule, we are talking about that many number of water molecule. Okay, when I say 1 mole of vitamin molecules, it means I'm talking that many number of vitamin molecules. Okay, so I think you understood, every time 1 mole is equivalent to a certain number, a quantity, and that quantity has 6.02 times 10 to the power 23 number of items, whatever we are talking about. Okay, so with that understanding, let's look how can we utilize the mole in our daily life, in our lab, right? It can be used as a conversion factor to relate the number of moles of a substance to the number of atoms or number of molecules. As I mentioned, 1 mole of something equals that many number of that thing. So if I'm talking about 1 mole of, let's say, element, okay, 1 mole of element, actually I should bring this way. 1 mole of oxygen element, then I'm talking about 6.02 times 10 to the power atoms of oxygen. Okay, if I'm talking about 1 mole of calcium element, I am talking about 6.02 times 10 to the power 23 atoms of calcium. Okay, similarly, if I'm talking about 1 mole of calcium molecule, it contains 6.02 times 10 to the power 23 molecules of calcium. Okay, so did you see what I mean there? So I'm using element. For element, the smallest unit is atom, and when I'm using the molecule, right, the compound, okay, and that will have the smallest items that are molecules. Okay, I should have written here calcium carbonate. That way you would see that 1 mole of calcium carbonate contains this many molecules of calcium carbonate. Now I think that makes more sense. Okay, so let's practice this conversion factor to convert from one to another. Okay, how many molecules are contained in 5 moles of carbon dioxide? Right? We are given a formula, carbon dioxide. It has 5 moles of CO2. Let's say a sample is 5 moles of CO2. Then how many molecules are there? Right? That is our desired quantity. So we can use this question just like the chapter 1 problems we solve using unit conversion. We can use that using dimension analysis. Okay, we can write out the conversion factors that 1 mole is equal to that many numbers, Avogadro's numbers of molecules, right? So I can write that equality into conversion factor this way or this way, right? So since I have the starting quantity 5 moles of CO2, I need to choose the conversion factor that has mole on the bottom, right? So I have to go with the second one, the one on the right hand side, to place it there. So I start with the starting quantity 5 mole and multiply that with the conversion factor. So moles and moles cancel out. Now 5 times 6.02 times 10 to the power 23, I will get the number 3 times 10 to the power 24 molecules of CO2. Right? If you want to use this in the calculator, how to hit that number? It's not popping up. Okay, you might have a button 10 to the power n in your calculator. Okay, you need to use that button. How to hit this number? Hit 5.0 times 6.02 times, and now click the button 10 to the power n, and in the place of n there will be a box flickering. Okay, write 23 there and then use the arrow to get the answer and enter it. You will get the answer 3 times 10 to the power 24 molecules of CO2. Okay, so let's see a few more exercise we can do on this conversion factor. The button is not working. Okay, I got it. How many molecules of water are there in 13 moles of water? Okay, so we do have exercise. Okay, students get confused if they do not understand exactly what the question is asking. Okay, so I'm going to show you here. The question is asking how many molecules of water, right? What it is given? 13 moles of water. So it means you need to connect the moles with the molecules there, right? And you know 1 mole by definition will have 6.02 times 10 to the power 23 molecules. So let's set up this question. Okay, I'll start with 13, okay, moles I have 13 moles of water. So I will place the 13 moles of water. And then I have to convert the moles into molecules, right? So I can multiply with the conversion factor. The conversion factor will have the mole, because I have a mole here on the top. I will have mole on the bottom. So I will write 1 mole, right? And I have to talk about the mole of water, not any other guy, right? It has to be water. So I write here 1 mole of water. 1 mole of water is equivalent to Avogadro's number of molecules. So I will write here 6.02, right, times 10 to the power 23, right? So that will be equal to, if you now use the calculator, right, this mole of water and this mole of water will cancel out. In the calculator, you will have 13 times 6.02, and now hit the button 10 to the power n, and on the n you write 23. Okay, I'm assuming you are using calculator something like TI 30, right, X. Then if you are using other calculator, you may have a button like uppercase EE that will also go for the exponent 10 to the power. So in that calculator, you can hit 13 times 6.02, shift EE, then hit 23, and you get the math. Okay, actually I wanted to bring the calculator here and show it, but my buttons are not working. I think like I may not be able to open this when I'm using the Kaltura. I do not know. I will explore that. Okay. But for now, when you multiply these two numbers, you will get 7.83 times 10 to the power 24. And since 13 has a 2 significant figures, right? 2 non-zero digits. So I can write the answer in 2 sig fig. So that becomes 7.9 times 10 to the power 24. That many molecules of water are present in 13 moles of water. Okay, is that clear? You can please review this question. Okay, you can close this, pause this video and work by yourself on this. Okay, and come back when you are done. Okay, now let's try the other one. How many moles of oxygen are there in 13 moles of water? Okay, so I start with, I have 13 moles of water, right? I have 13 moles of water, and then I use, okay, now I have to convert that moles, right? Water moles, I have to connect that with moles of oxygen. So I have to have mole of oxygen on the top. Okay, because that is what I need. Okay, mole of oxygen on the top, and I need to get rid of this mole of water, so I will write mole of water on the bottom. Okay, mole of water. So one new information that you will use it, okay, actually you have already learned this, I'm just recalling it. The 1 molecule of water has 2 molecule of hydrogen atom. You can say 2 hydrogen atom and 1 oxygen atom, right? This is what we have learned. 1 molecule of water has 2 atoms of hydrogen, 1 atom of oxygen. That is one information you can extract. You can also tell that 1 mole of water, okay, has 2 moles of hydrogen and 1 mole of oxygen. That is the information we get from the formula itself. This subscript tells you the ratio, right? So 1 mole of water contains 1 mole of oxygen. You see here 1 subscript, so I write 1 here. So now I can multiply 13 times 1 is simply 13, and 1 mole of water and moles of water, I can cancel that. So altogether I have 13 moles of oxygen, right? 13 moles of oxygen. Similarly, you can work for moles of hydrogen. Since the subscript is 2 here, so we will have 2 hydrogen mole per 1 mole of water. That will be now 26 moles of hydrogen, right? That is how we work for that. Let's try the third one. Okay, how many atoms of hydrogen are there in 1 mole of water? Okay, by definition, this comes from definition. By definition, 1 mole of water will have 6.02, right? Let me work this one, okay, because it is talking about the moles of hydrogen atom. So let me do thoroughly, okay, because 1, all right, I have to go with the 1 mole of water. I have to set up this problem. I will be a little slow. You can speed up the video if you wanna look at that. My writing is slow here. 1 mole of water will have 2 moles of hydrogen, right? Because this information we just got from the subscript H2O, right? H2O means there are 2 moles of hydrogen. So we have this H2O, 1 mole of, right? Let me write the text here. 1 mole of H2O. 1 mole of H2O has that 2 mole of hydrogen, right? And then the question is asking me about atoms of hydrogen. So from mole, I have to get the atoms. What is the relation? The relation is the definition of mole. 1 mole of anything contains Avogadro's number of that thing. It means 1 mole of hydrogen element contains 6.02 times 10 to the power 23 number of hydrogen atoms, right? So that is what the question is asking, hydrogen atoms. So my pen is not, okay, hydrogen atoms I can write. Now you can check back whether you have set up this correctly or not. 1 mole of water, 1 mole of water cancel out, mole of hydrogen element cancel out, and at last you have hydrogen atoms. These are the individual hydrogen atoms present in 1 mole of water. Okay, so multiply 1 times 2 times 6.02 times 10 to the power 23. The answer will be 1.20 times 10 to the power 24. Okay, so that is the answer. Please check your answer back. Now, let's try the last one. How many atoms of hydrogen enter your body when you drink 13 moles of water? Right? So, just like the example we just did, here it was 1 mole, right? Now we are talking about 13 moles of water. So if you remember, my earlier answer was 1.020 times 10 to the power, okay, 10 to the power 24, right? You can do the unitary method. So now just multiply this number by 13. Or you can set up just like how we tried it, right? You start from moles of water, then get the moles of hydrogen, and then get the atoms, the number of hydrogen atoms, okay? So 13 times 2 times 6.02 times 10 to the power 23 is same as multiplying the earlier number on section C by 13. That will give you, what is the answer? Let me see. Okay, let me see. The answer, if you write in 2 sig fig, this is 1.6 times 10 to the power 23. Okay, this 23 is the power. Okay, I do not have a power button here. So 1.6 10 to the power 23 is the correct answer, the number of hydrogen atom. Okay, now similarly you can practice for oxygen atoms. Please go ahead and do that. Okay, a little bit math heavy this slide, okay, because we are trying to convert the moles into molecules or atoms or vice versa. Okay, the whole concept that you have to understand is the definition of mole and apply that according to what is given and what is asked. Okay, now let's look on if we have any more extra math here. Okay, a little bit about now. In the lab, we do not measure the mole. We always measure the mass. Okay, we use the balance to measure the mass of certain compound. So in mathematically, we need to learn how to convert the mass into moles or moles into mass. Okay, so for that conversion, we use the molecular weight or formula weight of the compound. So by definition, the formula weight is the sum of atomic weights of all the atoms present in the compound. And generally, we report that in the atomic mass unit, AMU. Okay, this part is easy. You just need the periodic table that has the atomic weights written on it. Okay, let's practice this. Calculate the formula weight of iron sulfate. Okay, this iron sulfate means you have one iron atom, you have one sulfur atom, and you have 4 oxygen atom in one molecule of iron sulfate. Okay, so you just have to multiply how much each atom weigh, how much is their atomic weight, and then sum them up. Since you have one iron atom, this 55.85 AMU is the atomic weight of iron. This information you get from the periodic table. It means one iron atom weighs that much of atomic mass you need. Okay, one sulfur atom means 32.07 AMU. 4 oxygen atom means, since each one of them is 16, 16 times 4 is 64. So now add all this up, you get the formula weight or molecular weight of iron sulfate. Okay, so we will use the molecular weight to convert, use as a conversion factor, okay, to convert from moles to grams or grams to mole. How to do that? Let me show you. The molar mass is the mass of 1 mole of any substance. Okay, 1 mole of something will contain or weigh the molar mass of that thing. The value of molar mass of a compound is the value of its molecular weight. That is the value of 1 mole. Okay, so there is a relation. 1 mole of water, if you put that in a balance, then the balance will pop up the number 18 grams. Because 18 grams is the molar mass of water, the molecular weight of water. Okay, use the periodic table. How did we get that? We have 2 hydrogen, right? 2 hydrogen. Each of the hydrogen has the atomic weight 1.01. Okay, and then you have 1 oxygen atom. The oxygen atom has the mass 16 gram. So altogether the formula weight or the molar mass, or we say molecular weight, they are same thing. Okay, formula weight, molar mass or molecular weight. This is like you have to add the atomic weight and the number of atoms present there. This is 18 grams for water. So 1 mole of water weighs 18 grams of water. Okay, and then if you want to relate the mole with the number of molecules present, then this is something we just learned. 1 mole of water has that many, Avogadro's number of molecules of water, right? So we can get some problem, word problem, where we may need to convert the grams into mole, okay? And then we need to convert the moles into molecules or vice versa. Okay, so let's try something similar to it. How many moles are present in 100 gram of aspirin? Okay, the aspirin, its molecular formula is given. Whenever we have headache or we have fever, we take a tablet of medicine, aspirin, right? Aspirin, its molar mass is given here and the formula is given here. Okay, so how did the molar mass 180 comes from? Is 9 times 12 plus 8 times 1.01 plus 4 times 16, right? You multiply the subscript with the atomic weights, you get the molar mass, and it is given here in the question, so we can write it directly. Okay, how many moles are present in the 100 grams? So it means you need to convert the grams into moles. Okay, so the question has given us grams. You need to convert into moles. Okay, I like to write this way the direction, so that every time we look the question, we understand what is given, what it is to find out, and what can we use. To convert grams into moles, always use molar mass. Okay, so this is a little formula, little trick that we need to remember. Okay, use this one. So we are given 100 gram of aspirin. So I will just write here 100 point gram of aspirin. Aspirin is C9H8O4. I will just write ASP and then multiply that, right? We have to use the conversion factor, multiply that by the conversion factor relates. I have a gram here, so I need to write the gram on the bottom. Okay, how many grams aspirin is there? My hand is a little bit tricky here. This many grams of aspirin, I need to convert into mole, so I will write mole on the top. 1 mole of aspirin, okay, actually if you keep 1 mole of aspirin in the balance, it will weigh its molar mass, and molar mass is given here as 180.2, right? So 180.2 is the molar mass. It means 1 mole of aspirin has that many grams of aspirin in it. Now you can cancel the grams of aspirin with the grams of aspirin and you get the moles. So 100 times 1 divided by 180, right? That will be 0.555 moles. What did I do? Oh, okay. Get the new text over here. 0.555 moles of aspirin is the one I get. Okay, so what did we do here? We convert the grams that was given into the moles that was asked by using molar mass. Okay, molar mass could be given in the question directly, or you have to figure out by yourself. Okay, it depends on the question. Okay, so now let's look on if we have anything similar question here. How much would 2 moles of water weigh? Oh, this one you can directly say. 1 mole of water is 18 gram, then 2 moles of water is 36 gram, right? You can say it directly, or you can write it through the dimension analysis. Next one, how much would this many moles of carbon dioxide weigh? Oh, this one is a good one. Let's try. You start with what is given, 0.0542 moles of CO2, right? CO2. Now, you need to place the moles. I can write the mole MOLE, or I can write the short form MOL. Okay, both means mole. MOLE, mole, is not the short form of molecule. Understand that. Okay, so 1 mole of CO2, how much does it weigh in grams? Because the question is asking me how much is that weighing, right? So I need to get the grams. 1 mole of CO2 will weigh its molar mass. So I need to know what is the molar mass of CO2. If the question does not give me, I have to find that myself. There is 1 carbon, so I multiply 1 by 12. 12 is the atomic mass of 1 carbon, plus I have 2 oxygen, multiply that by atomic weight of oxygen. That means 12 plus 32 gives me 44 gram. It means that 1 mole of CO2 is or does weigh 44 gram. Okay, so we place it there, and now 1 mole of CO2, 1 mole of CO2 cancel out. I have this number times that in the calculator. When I hit those numbers, I will get some numbers. Since I have 3 significant figures in the starting number, I can write the final answer in 3 sig fig. So 2.38 gram is my final answer. Okay, so what we did in this question is we were given moles, we convert them into grams, and again we use the molar mass to do it. Okay, so either moles to gram or grams to moles, whatever is the question, okay, relating grams to moles or vice versa, whatever it is, always use the molar mass to convert from one to another. Okay, does that make sense? Okay, so let me see. In today's class we talk about the moles. Finally, one question that is already done. You can work on it by yourself. I can explain this. How many molecules are there in 325 milligram tablet of aspirin, and its molar mass is given? Okay, so this question is further asking one step more. Okay, because from grams you can convert into moles and use the moles and find it the molecules. Okay, how to set up? You go with the grams. Here actually milligram is given, and you convert that milligram into gram, right? Because 1 gram is 1000 milligram. I can place that this way. So I have here grams, and now the molar mass, right? One mole of aspirin will have this many grams of aspirin, right? And 1 mole of aspirin also has this many molecule, Avogadro's number of molecules of aspirin. So I can write directly here. Actually, I prefer to have one more step where I saw 1 mole divide by 180 times 6.02 divide by 1 mole. I would like that. And then you set up. Now milligram cancel, gram and gram cancel. You have molecules on the top. So the answer is, since the question was 3 significant figure, you write the answer in 3 significant figures. We have the answer here, 1.09 times 10 to the power 23 molecules. Okay, please practice this question by yourself. Here is a little bit direct shown because both of these quantities are equal to 1 mole. So it is placed this way. Okay, but you understood that. Okay. So please exercise, review these math problems, exercise this by yourself because it is a very important concept. Okay, so in our next class we will continue chapter 5. Thank you.